We've seen how to go from gram to mole and mole to gram, and how we can go from mole to molecule or atom, and atom or molecule to mole. And we even saw one problem where we went from atoms to number of grams. If you think about this, the unit that's common to all of these problems was the mole, and so I'm calling this mole the central unit. This diagram shows how the mole, the unit mole, is related to number of atoms or molecules and the number of grams. And you can see that a mole is equal to 6.022 times 10 to the 23, and that's either atoms or molecules. And yet a mole is also equal to the atomic mass in grams. So this unit map right here helps you realize how you have to do your conversions. Essentially, what would be the unit sequence that you need to do a particular conversion. So if in the problem grams are given to you and it asks you for the number of moles, you can see that it's a one-step conversion. But if the grams are given to you and it asks for the number of atoms, then you know you can go from grams to mole, then to number of molecules. So keep this little unit relationship and how mole is equal to something for each step in this relationship to use in problems, so it can help you think through how to do a problem. Well, so far we've been dealing with elements. Now let's look at compounds. If I have 1 mole of water, I'm going to have 6.022 times 10 to the 23 molecules of water. And we've done calculations based on that relationship. But what about mass? If I have 1 mole of water, though, I know that I have individual components in that mole of water. I have 2 moles of hydrogen and 1 mole of oxygen. From this 2 moles of hydrogen and 1 mole of oxygen, I can determine what the mass of 1 mole of water is. 2 moles of hydrogen will have a mass by using the molar mass of hydrogen. I can determine that 2 moles of hydrogen will have 2.016 grams. From the periodic table, I can see that 1 mole of oxygen is going to have a mass of 16 grams. If I sum these together, I can determine that 1 mole of water will have 18.02 grams. We call this the molar mass of water, just as we would call 1.008 grams the molar mass of hydrogen. So now, using the molar mass for molecules, we can extend this unit map to compounds. The only difference between this and the one that we saw before is now we realize if you have a mole of a compound, you sum up the atomic masses to get this relationship. And if you have a mole of molecules, you would follow this number with molecules. Remember, use this number only with atoms or molecules. Never have it in combination with any other unit. Now what we're going to do is apply what we just learned and apply the mole concept to molecules. The question is, how many molecules of carbon dioxide is in 2 grams of the compound? The first thing that I want to do is to determine the molar mass of carbon dioxide. I do this by summing the molar mass of 1 mole of carbon and the molar mass 2 moles of oxygen. I have 2 times 16 because the subscript on carbon dioxide has a 2 on the oxygen. I sum this together and I come up with that 1 mole of carbon dioxide is equal to 44.01 grams. I use this information to construct a fraction with 1 mole on one side of the fraction and 44.01 grams on the other side. So now I can take 2 grams as my starting point because that's my given in the problem, And I'm going to go from gram to mole, and then from mole to number of molecules. I need to make my fractions equal to 1. So 1 mole is 44.01 grams for carbon dioxide, and 1 mole is 6.022 times 10 to the 23 molecules. Remember, this number only goes with either molecules or atoms, with no other unit. I do my math and I come up with 2.7 times 10 to the 22 molecules. So now, here's another example. In the previous problem, I had to go from mass to number of molecules, and using that unit relationship, the unit map that I gave you in one of the previous slides, I had seen that I had to have the relationship of going gram to mole and then mole to gram. If I look at this question, it says, what is the mass of 0.5 moles of sulfuric acid? If I go back to my unit map, you can see that I can go from mole to mass directly. I don't have to go through any other unit. So now I know I need to figure out, since I'm going to determine mass, I have to figure out what is my molar mass. So to determine the mass of 1 mole of sulfuric acid, I'm going to take 2 times the molar mass of hydrogen, 1 times the molar mass of sulfur, and 4 times the molar mass of oxygen. If I sum that together, I get that 1 mole of sulfuric acid is equal to 98.09 grams. So now I write my given, I orient my fraction so that mole cancels out, and gram is the unit I end up with afterwards. And since 98.09 grams always goes with grams, or 98, the mass, molar mass, always goes with gram, I put that in the fraction with the gram. I do my math and come up with 49.04 grams. So if I go in way out 49.04 grams, well then I have half a mole of sulfuric acid. Now what I'd like you to do is to pause the lecture, try this problem, and then we'll go through how to do this problem so you can check your work.
To do this problem, we start with 3.2 times 10 to the 20 molecules. Then we think through our unit sequence. You cannot go directly from molecules to gram. You must go through mole. If you look at that unit sequence, you will see that number of particles goes to mole, and then mole goes to gram. And so I'm going to have to cancel out molecules and go to mole, and then cancel out mole and go to gram. To make each of these conversion factors equal to 1, I have to enter in some numbers. In 1 mole, there is 6.022 times 10 to the 23 molecules, so I will enter that into that fraction. And into the other, I determine the molar mass of aspartame. I do that by multiplying 14 times 12.01 plus 18 times 1 plus 4 times 16 plus 2 times 14.01, and that's going to give me 278. That's how many grams are in 1 mole of that molecule there. And remember that 6.022 times 10 to the 23 only is written with molecules or with atoms. Never write it with gram, never write it with mole. I do this math and I come up with 0.15 gram. Now, your calculator has in it a priority of doing multiplication before it does any addition. So in your calculator, you can enter in without any parentheses, you can enter in 14 times 12.01 plus 18 times 1.008 plus 4 times 16 plus 2 times 14.01, and you will come up with 78. Try it on your calculator and you will see you do not have to use parentheses and you do not have to press enter after every multiplication, and write down your number and then add them together manually. Your calculator will do multiplication before it does addition, and so it multiplies each of those individual numbers before it adds them all together.
Okay, let's try this problem. What I want you to do is try this problem by pausing the lecture and then pressing resume after you finish the problem.
To do this problem, we're going to first write down 250 milligrams. I cannot go from milligram to mole directly. I can go from gram to mole though. So I'm going to have to do a conversion of milligram to gram and then do a conversion from gram to mole. In order to do that, I have to go back to my prefixes and remember that milli is equal to 10 to the minus 3, so milligram equals 10 to the minus 3 gram. To figure out how to make my fraction of mole and gram equal to 1, I go to my formula and I see that it is 9 carbons, 8 hydrogens, and 4 oxygens in acetylsalicylic acid, so I do 9 times 12.01 plus 8 times 1.008 plus 4 times 16, and that gives me 180 grams in 1 mole of acetylsalicylic acid. I do my math and I come up with 0.0013 mole.
What I want you to be careful of is, in doing these problems, do not abbreviate molecule as MOLE. It's kind of obvious, isn't it? Mole is being used in these calculations, and if you abbreviate molecule as MOLE, then you're going to become very confused. Do not abbreviate molecule at all. All abbreviations will confuse you. You don't want to use an M, because we're going to be using an M later on in an abbreviation. Don't abbreviate mole. The only abbreviation that we ever use for mole is MOLE. Saves you a lot of writing, doesn't it? The capital letter M is reserved for molarity, and the little letter m is either meter or molality. You don't want to use abbreviations that are going to confuse you later on. So stick with the abbreviations that we've used, or don't abbreviate at all. It is not that much extra work to write something out.